Welcome. My name is Deko Mohammed. Today I want to focus on chemical formulas and equation. Remember, I saw that most of you were asking about moles, but for you to undertake question on moles, first you have to know how to write equations, how to write chemical equations. Remember, there may be some times where a question may require to write an equation for you to get the moles through moles ratio. So for you to know that, first I want to focus how to write the chemical formulas in equation. After you have known that, now we can go to moles and illustrate how we calculate the moles. So today I want to focus on how to write the chemical formulas and equation. Remember, in Form 1 you learned about the word equations of 3, whereby we have acid plus base will give you salt. Acid plus base will give you salt plus water. You also learned that acid plus metal, this will give you salt plus hydrogen gas. Lastly, acid plus metal carbonate, this will give you salt, water, and carbon 4 oxide. So this is a word equation. Want to see how to write this in a chemical equation. Let me start with the first one. We have an acid react with base. We have example of acids like HCl, hydrochloric acid. We have, let's say, example of acids. We have hydrochloric acid. This HCl. Also have sulfuric. This is H2SO4. We may have nitric acid, HNO3, and others, carbonic. We have so many acids. So these are the example of acids. We may also have example of base. We may have sodium hydroxide, calcium hydroxide, and among others. So, want to see if you react an acid with a base, how do you write the chemical equation for that? Remember, if you say like sodium hydroxide consists of two. We have sodium and hydroxide. Remember, sodium is Na, hydroxide is OH. Remember, valency of sodium is 1, OH is 1. So if they interchange, still we have sodium hydroxide, NaOH. If you come to calcium hydroxide, we have calcium is Ca, hydroxide OH. But remember, calcium has a valence of 2. If it has a valence of 2, hydroxide is 1. So we have the interchange. So we have calcium hydroxide, OH with 2. Remember, OH is a radical. So in the radical, first bracket it, then we write the 2 outside. It means the interchanges. The OH goes with 2, calcium goes with 1. Now we write a symbol equation here. I say I take sodium hydroxide, this is aqueous. We must know solubility of salt. We tackle in Form 2, we have salt as a topic. So you must know sodium hydroxide reacting, let me say we have hydrochloric acid. Hydrochloric acid, this is aqueous. This is a base, these are salt, they are reacting. We said they give us, this is a base, this is an acid. Acid plus base will give us salt plus water. You see? You see that this sodium will go with this chloride. So we'll have here sodium chloride, aqueous. That's our salt. Then you see this H2O, that forms the water, liquid. So we have sodium hydroxide plus HCl giving us sodium chloride plus water. So an equation must balance. So we confirm if the equation is balanced. Sodium, remember, this side is called the reactants. These are the reactants, and this is the product. Now we compare whether the reactant and the products are equal. See, sodium on the reactant side is 1. Sodium on the product side is 1. So sodium is balanced. Or oxygen is 1. Oxygen is 1. Oxygen is balanced. Oxygen is 1. Oxygen here is 1. Hydrogen here is 2. Hydrogen is 2. Chlorine is 1. Chlorine is 1. So the equation is balanced. So you must know the correct formula, how to write the formula of these chemicals, the steps, whether it's liquid, solid, aqueous, then the balancing. So normally our equation there's 3 things they must take care. Are the symbols correct? Like if written here sodium hydroxide NaOH with a 2, that is wrong because the valency are 1 1. So are the symbol correct? Are the states correct? Liquid, aqueous, solid, then correct balancing. So those 3 things must be taken care of: the balancing, the correct chemical symbol, and the state. So this is an example of an acid and a base forming a salt and water. Remember, this will be helpful when you're tackling your moles equations. Maybe you know the moles of sodium, you know the moles of HCl. You know the moles of HCl. For you to get the moles of sodium hydroxide, you can use mole ratio. Like this is 1 to 1. It means if moles of HCl is 0.5, the moles of sodium hydroxide will be 0.5. So if you mess up in the equations, so you not get the correct moles. That's why I wanted to tackle here first the chemical equations. Then later we know how we can complete how to calculate the moles, which is very easy. Most of students say it's very hard, but not that. So this is acid plus base. We want to see the next one, which is acid plus metal. Acid plus metal. This will give you salt plus hydrogen gas. Now I use HCl in the first, so let me use now sulfuric acid. Remember, sulfuric acid is H2SO4 aqueous. I react with any metal. Let me say I reacted with potassium. So it means potassium acid plus metal, we said will give us salt plus hydrogen gas. Our salt will form by the sulfate and the potassium. We will have potassium sulfate. But remember, the valency of potassium is 1 and sulfate is 2. So it means potassium valence is 1, sulfate is 2. If they exchange, so calcium will end up with 2. So K2SO4, that means you have right here K2SO4, potassium sulfate. And you have to know that all salts of sodium, potassium, and ammonia are soluble. It means here we have aqueous. So this potassium sulfate aqueous plus hydrogen gas. Remember, this is our salt. Remember, this is our metal. Then if you combine salt plus metal, you will get this. This is acid, sorry. This is acid. Acid plus metal will give us salt. Salt plus this hydrogen gas. So we have the acids, we have the acid plus the metal, salt plus hydrogen gas. This is how the perspective you look. We have another one, let's say hydrochloric acid, aqueous, reacting with zinc, solid. Remember, zinc, this fluorine will go with zinc, so we'll have zinc chloride. But remember, the valence of zinc is 2. Chlorine valence is 1. If they exchange, chlorine will end up with 2 zinc chloride plus hydrogen gas. Remember, this equation you have to balance. Hydrogen is 2, sulfate is 1, sulfur is 1, oxygen is 4, potassium is 1, So this equation was, if you look at potassium, here you have 2, here you have 1. So you have to put here 2. 2 potassium, 2 hydrogen, 4 oxygen, 1 sulfur, This equation is balanced by putting 2 before sodium. 2 before potassium. This one we have HCl reacting with zinc chloride plus hydrogen gas. So if we are to balance this equation, we have hydrogen 1, hydrogen 2. Now we need to balance hydrogen because the reactants are not equal to the product by putting 2 before hydrogen. 2 hydrogen. Chlorine here we have 2 chlorine. Zinc is 1. Hydrogen is 2. Now this equation is balanced. I think that's enough for acid plus metal. So if there's any scenario, you know how to deal with this. I want to look at the last one. Which is the last one is acid plus metal carbonate, which will give us salt, water, carbon 4 oxide. Let me take hydrochloric acid, which is aqueous. Let me say I reacted with zinc carbonate. Remember, zinc carbonate, zinc has a valence of 2, carbonate has 2. If they exchange, still zinc will have 2, carbonate will have 2, so they cancel, so we'll remain with ZnCO3. If they react, you see, we get salt. Our salt is going to be zinc and chlorine, which will going to form zinc chloride. We add water and carbon 4 oxide. Water, liquid, plus carbon 4 oxide gas. Hydrogen, let's confirm if they are balanced. Hydrogen is 1, hydrogen is 2. So you see hydrogen is not balanced, so you have to put here 2. 2 hydrogen. chlorine, 2 chlorine, 2 chlorine, 1 zinc, 1 zinc, 1 carbon, 1 carbon, 3 oxygen, 2 plus 1, 3 oxygen. So the equation is balanced. So that was what I wanted to focus in this class, how to write the chemical formula and chemical equations, which is a basic in chemistry. So you must know, for you to tackle an equation in moles, you must know how to write the correct formula, the correct equations, so that you can use in determining the number of moles or the molarity. Thank you for watching this video. Kindly note that we are not done with the gas laws. We only did the Boyle's law. We still remaining with Charles law, combined gas law, and Graham's law of division. We need to tackle those, but I want to tackle moles first before that, so that now you have known how to write the equations. We'll tackle moles. After that, we go back to our Boyle's law, our gas law. We continue from Graham's law and Charles' law. Thank you for watching. May God bless you. Thank you.